So from here to here, what would be the shortest distance? How would you do that? What would be the shortest distance? It would just be straight up and down, wouldn't it? And probably the shortest distance would have to be what to this line? Perpendicular. It would have to be perpendicular. So the distance is the length of the perpendicular segment between the point and the line. The length of the perpendicular segment between the point and the line. Okay, so on a totally different note, just because we had to stick it in here, what is the definition of a right angle? 90 degrees. Exactly. An angle that measures 90 degrees. Okay? An angle that measures 90 degrees. We might need that later. All right, if two lines intersect to form a linear pair of congruent angles, then you can say the lines are perpendicular. So these two lines right here form a linear pair, and the angles are congruent, have to be perpendicular. Okay, if angle 1 is congruent to angle 2, then G is perpendicular to H. Here's another one. If two lines are perpendicular, then they intersect to form how many right angles? 4. Okay? So if A is perpendicular to B, then angle 1, angle 2, angle 3, and angle 4 are right angles. We could also say 90 degrees because of the definition of right angles. All right, in the diagram, angle 1 is congruent to angle 2. What can you conclude from the diagram? We could say they're what? Not parallel, but yes. If we're told that these are congruent, based on theorem 3.8, we could say that A is perpendicular to B. If you want to put in parentheses here, theorem 3.8, that's fine. What? They form 4 right angles. Very good. That's if you want to. You don't have to. You could put theorem 3.9. What else could we say about angle 1 and angle 2? This is kind of like a little nitpicky kind of one. That they're all 90 degrees. Okay? We could say they're all 90 degrees, all right? All 4 angles are 90 degrees. And it kind of is useful when you get to start solving some proofs. And you say that because of the definition of right angles. Okay. Theorem 3.10. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So I want you to draw a picture here. Here's A, B, and C. And then it says in here, if two sides of two adjacent acute angles are perpendicular. So I'm going to draw a line here. Here's my two adjacent acute angles. And if these two sides are perpendicular, those two sides are perpendicular, then we can say that the angles are complementary. So let's label this angle 1 and angle 2. So to use symbols here, I could say this, I could just reword this in symbols. If ray BA is perpendicular to ray BC, then angle 1 and angle 2 are complementary. Please tell me you remember what complementary means. They add to 90 degrees. Hi.
Can I pick up the stuff from the table? Like the quotes?
So let's use this. Find the value of x. So basically, what does this tell us right here? That these two lines are perpendicular, correct?
Yep.
Therefore, I can assume that this angle is also what? 90. So here you can say it is 90. I'm not assuming. I know it is based on the theorem. Okay? So I'm going to say perpendicular lines form 4 right angles. Okay, so therefore I can say that 51 plus 2x minus 11 equals 90 degrees. Then I add these two together and I get 40 plus 2x equals 90 degrees. Subtract 40. What property is this that allows me to subtract 40 from both sides? Subtraction property of inequality. Of equality, not inequality. Two x equals 50. What does x equal? 25. It's not degrees, it's just 25. Okay? All right, turn the page. Or flip it over, sorry. All right, here's a couple of more theorems for you. You may be wondering if you have to remember the names of all of these. Not necessarily, as long as you can explain them, the reason for using them. Okay, you don't have to know the specific names or the numbers. Perpendicular transversal theorem. If a transversal is perpendicular to one of the two parallel lines, then it is parallel to the other. That's not what I want to say. What should I say there? Yeah. Perpendicular. I am having it. I'm trying to quit coffee, so you guys got to maybe like cue me in a little bit here. Your brain gets a little, yeah, trying to go off of it. All right, if a transversal is perpendicular to one or two of parallel lines, then it is perpendicular to the other. So I can just put this right here. Since this is perpendicular to this one, the transversal is perpendicular to this line, it's also perpendicular to this line that's parallel to that line. If H is parallel to K and J is perpendicular to H, then J is perpendicular to K. All right, lines perpendicular to a transversal theorem. So it's kind of the flip-flop. In a plane, if two lines are perpendicular to the same line, then they are what? Parallel. Very good. To each other. So, right here, these two lines are perpendicular to the same line. I can just put these little triangles on here to show that they are parallel. If M is perpendicular to P and N is perpendicular to P, then M is parallel to N. Okay? So, let's look at this. Determine which lines, if any, must be parallel in the diagram and explain your reasoning. So what do you see? What do you see, Courtney?
Line R and S are parallel.
R and S are parallel for what reason?
They're perpendicular, lines perpendicular to a transversal theorem.
Okay, so they're both perpendicular to, let's say, X, right? Yes, okay. I just put because X is perpendicular to both. And I know we should just say that that's enough if you don't remember the name of it. Okay, X is perpendicular to both. Okay, what's another pair? X and Y, because why? Yeah, you could say X is parallel to Y because R is perpendicular to both. Okay, is there more?
Yeah.
What else do you see, May?
Y is parallel to Z
How come?
because it's
I'm sorry, it's what?
No.
That's a little tricky, that one.
Yeah, no.
There's another reason for it, but let's get to it first. There's one other set we can say before we say y and z. What is it, Connor?
X and Z.
X and z. Let's say x is parallel to z because what line is perpendicular to both?
Perpendicular to both.
Okay, now we actually can say that y is perpendicular to z because of what property? Yes. Y is parallel to z, excuse me, because of the transitive property. Do you all see that? We've said that these two are parallel. We've said that x and z are parallel. Therefore, y and z have to be parallel to each other. Okay? Oh, look. Given that line ED is perpendicular to line EF, prove, not conclude, prove that angle 7 and angle 8 are complementary. So, I know I want you guys to usually do this in words, but I'm just going to set up a little table, and then you guys could go from words. So, here's what I want you to do. Just make a little T-table, like rough draft kind of thing. The first thing we always state is what? The given. So line ED is perpendicular to line EF. If that's true, what can we, this is given. What can we say about this angle if that's true? It's a right angle or it's 90 degrees, right? So then angle DEF is a right, I'm abbreviating, a right angle. Because perpendicular lines intersect to form right angles. So because we've justified that it's a right angle, what can we say about its measure? It's 90 degrees, so that's what we do next. Now we can say, well, the measure of angle DEF is 90 degrees by the definition of right angles. What we're trying to get to is we're trying to get to prove that they're complementary, meaning they add to 90 degrees. So that's why I'm bringing that 90 degrees in. Okay? What else can we say about this picture? Does anybody have any idea what else we might say about this picture? Yeah.
I don't know. Like the bisecting thing isn't like half.
Oh, we don't know for sure. It looks like it, doesn't it?
Yeah.
But we do know that they do what?
Bisecting.
Not that it bisects, but they do what?
Absolutely.
Let's say that. Is that what you were going to say?
Yeah, I was to say measure of angle 7 and measure of angle 8 equals 90 degrees.
Right on. I couldn't have written it any better myself, okay? So I'm going to just, well, before I go there, I'm going to say the measure of angle 7 plus the measure of angle 8 equal, I'm going to just say they equal this angle right here, okay? Equal, I know this is tight here, the measure of angle DEF. If you add them together, they equal that because of the angle addition postulate. Then we're going to go with what Connor said. So we've proven that they add together because of the angle addition postulate. Now we're going to say, well, they add together to equal what measure? 90 degrees. Measure of angle 7 plus the measure of angle 8 equals 90 degrees. Just based on substitution. We know that DEF is 90 degrees, so we can say now that it does add together to 90 degrees. Well, if that's true, then the two angles have to be what? They do. Definition of complementary angles. Angle 7 and angle 8 are complementary. By the definition of complementary angles. So let's go through this thought process one more time before I let you go. First we wrote the given. If that statement is true, then that forms a right angle. Then we said, well, I know that I have to somehow say that the two angles add to 90, so I'm going to say that the measure of that right angle is 90. Then I can state, well, the two angles add together to equal that big angle because angle of addition postulate. Well, if that's true, then they add together to equal 90 degrees based by substitution right here. Then I could say they're complementary. So I know I did it in this form. I probably would have you write it out otherwise, but